Good day! Today we were going to discuss solving logarithmic equation. Let us first know the step on solving logarithmic equation. First one, use the properties of logarithms to combine terms containing logarithmic equation in the single term. In this step, we have to remember the rules of logarithm for us to easily simplify the expanded given equation and vice versa. Number 2. Write the equation in step 1 in exponential form. Recall that exponential form would be logarithm of x with the base of b is equal to y. And this will be equivalent to b raised to y equal to x. Third, solve the indicate variable. The last step would be check your solution to make sure the possible solution do not result in the logarithmic of negative numbers or 0. To widely understand and apply this step in different equations, let us proceed with the example.
First example, logarithmic of 27 with the base of 3 is equal to x. This example is already in its simplified form as it does not use subtraction or addition. So we don't have to simplify it anymore. So what we have to do now is to express it in its exponential form, which again in the pattern of logarithmic of x with the base of b is equal to y, and that will be equivalent to b raised to y is equal to x. So the outcome according to the pattern and the equation will be 3 raised to x is equal to 7. Next step, as we can notice the two terms have different bases, and for us to solve logarithmic equation, it must have the same bases. Therefore, we have to write 27 into its exponential form using the base of 3, which will become 3 raised to 3. We have now an equation of 3 raised to x is equal to 3 raised to 3. We can say that our two terms are now equal since they have the same bases, and with that, as stated in exponential rules, we can now bring down the exponent and equate them to each other, which will result in x is equal to 3. To simplify it, using the exponential form of the given equation, substitute 3 for the value of x, we will have 3 raised to 3 equals 27. 3 raised to 3 will become 27, so it will now become 27 equals to 27, meaning to say they are now both equal. In conclusion, we can finally say that our solution is correct.
Let's now move on to the second example. We have logarithm of 4 with the base of 2 plus logarithm of 16 with the base of 2 is equivalent to x. So in this example, we can observe that the given is still in the expanded form because it uses addition as an operation. And to turn this equation into its simplified form, we need to apply the product rule, which is in the form of logarithm of m with the base of b plus logarithm of n. With the base of b will be the equivalent to logarithm of m multiplied by n with the base of b. Therefore, we have to use multiplication. With this rule, we will get a logarithm of 4 multiplied by 16 with the base of 2 is equal to x. Next step, we are going to simplify 4 multiplied by 16 and that will be 64. Now, the equation will become a logarithm of 64 with the base of 2 is equal to x. And after that, let us now transform the equation into exponential form by following our pattern b raised to y is equal to x. And with that pattern, we will now have 2 raised to x equal to 64. Next, we have to solve for the x, and for that to happen, we have to express both terms with the same bases. In this way, let's transform the 64 into its exponential form, using the base 2, which will be the equivalent to 2 raised to 6. Right now, we have 2 raised to x is equal to 2 raised to 6. They are now equal since they have the same bases. Let's proceed to bringing down our exponents, and with that we will have our final answer, which is x is equal to 6.
And that's how to solve logarithmic equation and their solution. Thank you for listening. God bless.